All right, the soundtrack continues. Okay, so find all roots of each polynomial function. So remember, the degree will tell you how many solutions you're looking for. So if you look at all four of these, the degree is 3. All of them, we'll know we're done when we found 3 solutions. So this is 2.5, 2.6, if you look back in the notes, but we'll go through it. All right, so the first thing is, I don't know how to factor this. If I could factor it, then I could use zero product property and solve, but I'm kind of stuck. So I got to use all the methods, all the skills we've been working on this unit. So first off, I find the factors of P, find the factors of Q, and I'm going to make my list by doing P divided by Q. Take every P divided by every Q. So I have 1 and 1/3, and then I have 3 divided by 1, which is 3. Sorry, I did 1 divided by 1, 1 divided by 3. Now 3 divided by 1, 3 divided by 3, but I already have 1. And these will all be positive and negative. So most of you will go to your calculator at this point, type that sucker in, and then look for the zeros. Remember, if it bounces, that means that it's going to have multiplicity. We do not have multiplicity on this one, but just a reminder when you're looking at the graph. I'm not going to use the graph on this one, though, because I want to just talk about the remainder theorem. So what I'm going to do is I'm going to take this, and I'm actually going to plug in, and I'm going to pick, because it starts, ends in negative in 3, and because it ends in negative 3, I have a feeling negative 3 is going to work. So I'm going to use the remainder theorem. I'm going to plug in the 0, negative 3, the possible rational 0, negative 3, and see if it actually works. Remember, the goal is to get it equal to 0. So 3 cubed is 27. So that's going to be a negative 27, but 27 times 3, 3 times 7 is 21, carry the 2, 3 times 2 is 6, 7, 8. All right, negative 81. 3 times negative 3 cubed is negative 81. And then negative 3 squared is positive 9. 9 times 11 is 99. And then 5 times negative 3 is negative 15 minus 3. All right, so negative 81 plus 99 is, so 99 minus 81, right, is going to give me 18. 18 minus 15 is 3. 3 minus 3 is 0. So it is indeed 0. That means negative 3 is one of the zeros. So I'm going to take that negative 3. I know that that one is one of them. I'm on a quest to find 2 more, though. So I'm going to take it into its factored form, and I'm going to divide it out, because since I already know it's a 0, I'm just going to get it out of the polynomial. Factor it out, divide it out. So I take this, write it right here. So I'm just doing my division, dividing the x plus 3 out. I'm going to get 3x squared, which when I multiply that, I'll get 9x squared. But remember, I didn't want 9x squared. I wanted 11, so I need 2 more, which gives me 2x there, which gives me 6x. I overshot it a little bit, so I got to get rid of an x, which gives me negative 1 there, and that leaves me with negative 3, so it worked perfect. So right now I know x plus 3 multiplied by 3x squared plus 2x minus 1. Now, because it's a quadratic, I can use my skills from last year. So I can use Glasses method, A times C, box method. I can factor this guy, hopefully. So 3 times negative 1 is negative 3. So I did my A times my C. Now I got to think of numbers that add to give me negative 3. Sorry, multiply to give me negative 3, but add to give me 2, that middle term there. All right, so that looks like it's going to be 3 times negative 1. So this will be 3x, that'll be negative x. Then I'll have my 3x squared and my negative 1. Okay, so then when I factor that, that means that this had to be 3x, that had to be x to get 3x squared, right? And then this had to be plus 1, and this had to be minus 1. So I know the factors are x plus 3, which I'm just bringing down from before, 3x minus 1, and then x plus 1. So I just took this guy that I started with and got it into its 3 factors, because there were the degree was 3, there's 3 zeros, 3 factors. Now I can use the zero product property, and solve. Now, remember, we already knew negative 3 was 1, but there it is, double proof. Add 1, 3x equals 1. I'll divide by 3. I'll get x equals 1/3. That's the second solution. And then negative 1. All right. With the grand finale from the band. Oh, wait, let's do another one. Let's do 25, not create a new video. So pause this, try 24 if you want, but I'm going to do 25. All right, so 25. So I cannot factor that. Nope. So there are 3 solutions. I can't factor it, so I've got to use the new strategies we've been learning. So I'm going to look at my P's, look at my Q's, use the remainder theorem, because I don't want to do the calculator. But if you're comfortable with the calculator, you can use the calculator, of course, see if you can find those zeros. So I have 1, 18, 3, 6, 2, and 9. And then here it's just 1. So it's every P divided by every Q, so it's just going to be that list. 1, 18, 3, 6, 2, 9. But remember, it's plus or minus to everyone. Everyone has a positive and a negative. Okay. So I'm going to go through and I'm going to use the remainder theorem because I didn't want to switch back and forth through the calculator. But I'll tell you what, I already tried 3 and 3 worked. So remainder theorem says if you plug it in, and you get and if you get an output of 0, that means it's a factor, it's a 0, the remainder would have been 0. So 3 cubed is 27, 3 squared is 9, 9 times 7, 63, and then I have, yikes, negative 36 times 3, that's, do that real quick, 18, 3 is 9, 108. Okay, so when I do 27 plus 63, I'm going to get 90, right? So 108, so 90 minus 108 leaves me with negative 18 plus 18. Yep, it equals 0. So I know that 3, oh, last time was negative 3. I was like, did we get the exact same one? Nope. 3 is the actual, one of the actual zeros of the 3. All right? Now I could go through and test more, but I already found one that works, so I'm going to just divide it out now. So remember, I got to get it into that factor, though. Okay, so I'm going to divide an x negative 3, divide that out. So that will leave me with x squared okay. Sweet. Okay, so I know right now x minus 3 times x squared plus 10x minus 6, those two multiply to create that thing up there, right? We already know 3 is a solution, so right here, there's my 3, x equals 3, there's my 0, my root, and then this holds 2 more. So I'm going to try to factor it, but I can't think of anything that multiplies to give me negative 6 but adds to give me 10. So in order to solve this one, I'm going to have to use, I'm going to have to complete the square. So remember to complete the square, I put the x squared in, and then I half 10x, which gives me 5x and 5x. It should be a perfect square. Remember, squares are the same width and length. So x squared and 5x, x squared 5x, same width and length, which means that had to be x plus 5, x plus 5. And then to complete the square, I should have got a 25 right there. But notice, I can't have a 25 there. I need a negative 6 there. So this is going to be, so I got to think. So 25 plus what gives me negative 6? That looks like it's going to be negative 31. Yes. All right. So I have x minus 3 times x plus 5 squared completing the square, x plus 5 times x plus 5 minus 31. So now I use the zero product property, which, remember, we already knew this one was 3. Then I'm going to do the same thing here. So now I just have to solve, and I'll have my other two solutions. So I'll add 31. Then I got to get rid of that square, so I'll take the square root, and I'll be left with x plus 5 equals plus or minus square root of 31. 31's prime, so I can't really do anything with that square root. So x equals negative 5 plus square root of 31, and negative 5 minus square root of 31. You don't have to write them separately, I just did. So there's my three solutions. Check, check, check.